Hi everyone, a very good morning to all. As it's time to discuss, I said you already, the questions, the most important questions, 5 mark and 3 mark questions for the board examination. So the very first part is about 5 mark questions, and the very first thing is I am going to discuss now 5 questions, 5 mark questions. So let's see what are all the questions and how to understand them in a simple way. So let's begin with the very first question. So here is our first question. State Gauss law in electrostatics. Derive the expression for electric field at a point due to an infinite long charged straight conductor using Gauss law. So first thing, they're asking to define Gauss's law. So first thing is Gauss law. Now, so Gauss's law. So what is Gauss law definition? Gauss law definition is the net or total electric flux linked with a closed surface, linked with any closed surface is equal to the ratio of net charge enclosed to the permittivity of free space. That is, you consider any closed surface, any closed surface. There are so many charges plus Q1, plus Q2, minus Q3, like that. If there is any charge outside, then the Q net you have to consider as Q1 plus Q2 minus Q3. You should not consider any charge even just outside also. Now this is the total net charge. Then the total electric flux linked with the surface is equal to Q net by epsilon naught. This is the Gauss law. So the total or net electric flux linked with any closed surface is always equal to the ratio of total net or net charge enclosed by epsilon naught. So that is what the definition of Gauss law. Then they are asking to derive the expression for electric field at a point due to an infinite long charged straight conductor using Gauss's law. Now, so let's derive the electric field due to an infinite long charged straight conductor. So whenever you want to do the derivation, first write down the result. So here they are asking electric field due to an infinitely long conductor having uniform charge density. There are three types of charge densities: linear, surface, volume. And here linear conductor means the distribution is linear distribution, linear charge density lambda. So the electric field due to that is given by 2k lambda by r, where lambda is linear charge density and r is perpendicular distance of point from the conductor. Now this is the result. Now let's take or let's show the result. Now you take it like proof. So now we are going to prove it like. Now first thing, whatever element they are telling, consider that element. Consider an infinitely long uniformly charged in conducting rod or wire. Now let's take this is one wire of infinite length. Now it is having the uniform charge density lambda. So linear charge density lambda equal to actually charge per unit length. Now let P be the point at a perpendicular distance R, like this is one point P. Now at P, electric field due to wire is E. Now you have to imagine, you have to apply Gauss law. But whenever you want to apply Gauss law, you need one closed surface. But here there is no closed surface. So when there is no closed surface, you have to imagine one Gaussian surface. So to enclose charge, imagine Gaussian surface. As wire is cylindrical shape, imagine one cylindrical shape around it of same radius. The point distances are, the cylindrical radius is also R. Now total flux. So total flux linked with cylinder equal to Q net by epsilon naught. You consider that length of that cylinder you imagined is L, then Q net will become lambda L, because lambda is charge per unit length. Per unit length lambda means for this much of length L, the charge will become lambda L. Now the other formula, that is flux, electric flux formula. What is the formula actually? Actual formula, mathematical formula. Flux equal to E bar dot A bar. And here total flux means here E is electric field, A is area. If you observe the diagram, there are two surfaces, circular surfaces, top surface and bottom surface. And there is one curved surface. So curved surface. So total three surfaces. But when you consider, see here, this is the direction of area and this is the direction of area. N cap means normal to the area. But for the curved surface, this is the direction. But electric field is always either towards or away from the charge. So electric field direction is like this. So electric field is horizontal and area direction for circular surfaces are vertical. So the angle between them is 90. So cos 90 will become 0. So the flux linked with the top and bottom surface is 0. So that flux total when you consider, there is one surface A1 bar plus E bar dot A2 bar plus E bar dot A3 bar, where A1 is top surface. A1 is top surface, this one. This is A1. This is A2. And the curved surface is A3. Now, this flux will become 0. This flux will become 0 because theta 90. Because E bar dot A bar means what? EA cos theta. So the total flux now will become only E bar dot A3 bar, that is E into A3 is surface area, lateral surface area of cylinder, that is 2 pi r h or L, length or height. Now that is equal to Q net by epsilon naught, where Q net is lambda L by epsilon naught. Now L get cancelled. Then the electric field equation will become E equal to this 2 pi r you take other side, lambda by 2 pi epsilon naught r. Now you multiply with 2, divide with 2. So E will become 2 lambda by 2 into 2 denominator 4 pi epsilon naught r. But 1 by 4 pi epsilon naught is nothing but what? K. So 2k lambda by r. So this is the final result, 2k lambda by r. This is the result. So you can say like hence proved. So this way you take the result first, you give the result and then prove it. That is the method to do any derivation. So this is how you can apply Gauss law in deriving the electric field due to an infinitely long, uniformly charged thin wire, thin conducting wire or rod. So once check it properly, see. So everything I have written in a simple language. So what is the definition, what is the result, and what are the quantities associated with it, and how to approach it. So please just try to understand each and every step. Now, so the second question is, derive an expression for electric field due to an electric dipole at a point on axial line. So here we are talking about electric dipole. So it is better first to define what is electric dipole, the very first thing. So what is electric dipole? So electric dipole nothing but what? It is a combination of, two equal and opposite charges. It is a combination of two equal and opposite charges separated by a small distance. So it is a combination of two equal and opposite charges separated by a small distance. Like this is one charge minus q, this is one charge plus q separated by a distance, and that distance we consider 2L. Here 2L is distance between them, not L is distance. Distance between them. Now, every dipole has some dipole moment. So the electric dipole moment is the strength of, is nothing but, is the strength of dipole to produce electric field. So that dipole moment we have defined as any charge, because both are same charge into distance between them. That is what we have to understand. Now, so this is the electric dipole moment and what the definition of electric dipole. Now when you consider this is the dipole minus q plus q, if you draw a line along the line, if you draw an axis along the line joining the charges, that is called axial line. And if you draw a line perpendicular to axial line and passing through center, that means this distance will become L, this distance will become L, and this is called equatorial line. Now, the dipole moment always directs from negative charge to positive charge. Now here, let's consider a point P at a distance R from the dipole center on axial line. Then the electric field at that point is 2 kpr by r square minus L square whole square. And as distance between the charges is very less, and that will be approximated as 2 kp by r cube. So this is the result. Now we have to prove it. So for the proof, see, consider point P on axial line at a distance R as shown. Now, see here, this is the dipole minus Q plus Q. This is the center. This is L. This is L. Now, this is the axial line. And I considered a point P. Now, at a distance R from the center. Now, there is one electric field due to positive charge, and the electric field due to positive charge is away from it always. So that is E plus Q. and there is one field due to negative charge, but field due to negative charge is towards the charge. Now, the distance of the point from the negative charge will become, see, this is L plus R. So, total will become R plus L. Now, the distance of positive charge, this will become, see, this, only this. This is L and this total is R. So, it will become R minus L. One is R plus L and another one is R minus L. Now, first thing, E plus Q is electric field due to positive charge, and it is given by E plus Q equal to KQ by R minus L whole square. Similarly, E minus Q is electric field due to negative charge, and that is given by E minus Q equal to KQ by R plus L whole square. See, don't take minus charge means minus Q, because electric field is a vector quantity, only direction is important. Now, here in comparison, as here in place of here in E plus Q, E due to plus Q, denominator R minus L, E due to minus Q, denominator R plus L. So denominator more means value less, so that E due to positive charge is greater than E due to minus charge. So that resultant electric field at P is given by resultant field at point P, that is axial point, that's why I am taking EA, that will become greater minus smaller. Why? Because both are vectors. Now two vectors in opposite direction means theta 180 degrees, so the resultant will become A minus B or B minus A, greater minus smaller. And if you consider this, see, greater minus smaller, so that now the resultant will be in the direction of greater. So this is the direction of what? Resultant electric field. So the resultant electric field along P bar direction, dipole moment direction. So that here if you substitute EA equal to, so KQ by 1 is R minus L whole square minus KQ by R plus L whole square. Now you take KQ common. So R plus L whole square minus R minus L whole square whole divided by R minus L whole square into R plus L whole square. Here A plus B whole square minus A minus B whole square. So there is a formula for this, A plus B whole square minus A minus B whole square. So the formula is A plus B whole square minus A minus B whole square equal to 4AB. You just substitute. Also in the denominator, A plus B into A minus B is there. That will become A square minus B square. So that it will become 4Q into KQ into 4RL 4AB by, both are having square. Now I can write it as R minus L into R plus L whole square common. So that it will become, now this 4 I will write it as 2 into K into Q into 2L into R. I have written 4 as 2 into 2. And here r minus L into r plus L is r square minus L square whole square equal to, why I have written like this is 2k q into 2L, nothing but electric dipole moment as we defined in the beginning. So 2kp r by r square minus L square whole square. This is the electric field due to dipole. Now, as the distance between the charges is very much lesser, now r square minus L square is approximately equal to r square, because L square is even lesser, so negligible compared to r square. So that r square minus L square whole square is approximately equal to r power 4. Now the electric field on axial line will become 2 kp r by r power 4. So r, it will cancel, cube will come. So the final result is 2 kp by r cube. So then you can say like hence proved. So this way you can define each and everything. You can define each and every term associated. Then you can take the one by one step derivation so that you can prove the result properly. Because in theory exams, step mark will be there. Each step is important. So try to understand and try to solve it. Now, let's see the next question. Now, the next question. So, derive an expression for electric field intensity due to an electric dipole at a point on equatorial line. Now, same thing again. So, first we have to define electric dipole. So, what is electric dipole? See, I am not defining because just before we have done. And then what is electric dipole moment? You have to define. Now, after that, electric field due to a dipole at a point, at any point on equatorial line. Equatorial line. Now, equatorial line. E equatorial is Kp by r square plus L square whole power 3 by 2. As L is very much less than R and it is approximated to Kp by R cube. This is the result. Now let's try to prove it. Now, proof. Compared to the previous one, axial line case, this is little bit difficult. Now, consider a point P at a distance R from the center of dipole. Now see here, this is the dipole minus q plus q. Now this is the center and this is the equatorial line, right? Now consider a point P at a distance R from it, from the center. Now again, there are two electric fields. One is due to, see again, there are two electric fields due to plus Q and minus Q as shown. Like, see here, this is the distance of positive charge, and positive charge means field will be away. And this is the negative charge and the field will be towards. Now both are not along same direction so that you can add. Both are not along opposite direction so that you can subtract. They are in different directions. That's why you have to take the reference axis, and if this is theta, obviously this is also theta. So that you can go for what? Then this is also theta, resolution of vectors. Just like, see, this is the electric field due to positive charge, E plus Q. This is the electric field due to negative charge. Now that point P you consider, so here the point P, now one field is like this, E plus Q, and another field is like this, E minus Q, and this is the angle theta. Now, if you take components, this component will become E minus Q cos theta. This component will become E minus Q sin theta, because every vector can be divided into two components along two perpendicular directions. And the direction with which it makes angle, in that direction cos will come, in the perpendicular direction sin will come. Similarly, E plus, if you divide, this will become cos component, and perpendicular will become E plus Q sin theta. Now here in the first diagram, if you see, so this is the distance of the charge from the point P, where this is L, this is L, this is R, this you take it as X. So this is the distance of the point from the charges, and both are same. If you look at the triangle, see this one, like this one. So one right angle triangle is there like this, where this is X, this is R, this is L. Then X square equal to R square plus L square. This is what? The right angle triangle. Now, here, the electric field due to positive charge and the electric field due to negative charge, both are same. That is kq by x square, because distance is same, charge is same. Where x square we have seen already, R square plus L square. Now, here if you look at it, see, along vertical direction, components get cancel each other. Components get cancel each other. See here, E plus Q sin theta, E minus Q sin theta. But E plus Q equal to E minus Q. So both will get cancel each other. Therefore, resultant electric field at P will become, that is on the equatorial line, that's why E is one component E plus Q cos theta plus E minus Q cos theta, but both are same. So that 2 E plus Q cos theta or E minus Q cos theta. This is the net electric field. So E plus Q, E minus Q already we have. But what is cos theta? See here again. Here cos theta means, in this right angle triangle, when you look at it, cos theta means adjacent. This is the adjacent, L by hypotenuse is X. So L by X. Now here if you take the net electric field is 2 E plus Q cos theta, where cos theta value already we have taken, that is L by X. Now substitute. So 2 into E plus Q is KQ by X square. Cos theta is L by X. Now Here it will become like k into q into 2l. I can write it as x into x square is x cube. Now, where x square is r square plus l square, then x will become r square plus l square whole power 1 by 2. Root will come. Root nothing but power 1 by 2. Then x power 3 will become r square plus l square whole power what? If you cube both sides, so 3 by 2 it will become. So here k into p by x cube, where x cube if you substitute kp by r square plus l square whole power 3 by 2. So this is the result of electric field due to dipole on equatorial line. But as we know, here L square is very much less than R square. Then R square plus L square whole power 3 by 2 approximately equal to, now L square negligible, R square whole power 3 by 2. So x power m whole power n, x power m into n. So it will become square 2 to cancel R cube. So that the electric field will become Kp by R cube. So then you can say that hence proved. So this way, here the calculation became little complicated because we have taken vector resolution, then we try to find out, and so here if you understand this diagram properly, first if you draw the diagram properly, then you can get it correctly. So this is how you need to understand. So this is the electric field due to an electric dipole at a point or at any point on the equatorial line. Now, the fourth question, that is, derive an expression for electric field due to uniformly charged thin spherical shell. This is also one of the Gauss law applications. Now, here electric field due to uniformly charged thin spherical shell is given by, so the electric field is 0 kq by r square, kq by r square. This is for r less than r. This is r equal to r. This is r greater than r, where r is distance of the point, distance of the point from center of the sphere, from the center of the sphere, and capital R is radius of the sphere, and capital Q is the charge given to the shell or sphere. Now we have to prove it. Now let's consider a thin spherical shell having uniform charge distribution and radius capital R. So this is like one spherical body is there. You have given some charge Q and it will distribute everywhere on the outer surface only. Now, this is the radius so that you can get three different points. See here. One is you can get at any point inside. One you can get at any point on the surface. One you can get at any point outside. Like A, B, C. Now, the very first thing is case 1 at an inside point, that is R less than capital R, RA. Now when you consider that, see here, this is the sphere, this is the charge. Now charge is only outside because inside no mass, no charge will stay. It is a shell. Now at a distance R, when you consider, you imagine one sphere. Now what is this one? Gaussian surface. Gaussian surface. Now for Gaussian surface, charge enclosed, net charge enclosed is how much? 0. Implies, according to Gauss law, flux is also 0. So flux means nothing but integration E bar dot A bar for closed surface, that is 0, implies electric field is how much? 0. Area will not become 0. So that the total electric field inside is 0 as no charge resides inside the shell. So at A, that is inside point, the electric field is 0 always at any point. Now you consider outside point. So outside point when you consider, that is case 2. Now you just take like case 2. So what is that? For R greater than capital R. Now this is the sphere, you have given a charge Q. This is the radius. Now the point is outside. Now also you imagine one Gaussian surface. Now this is the Gaussian surface. Now this is the Gaussian surface. Now total charge enclosed within the Gaussian surface. How much now? Q only. The only charge which is there inside the surface is spherical shell. Total shell is inside. Now what is the total charge inside the Gaussian surface? Q. So that now total flux, that is integration E bar dot ds bar equal to Q by epsilon naught. Now E into integration ds equal to Q by epsilon naught. And charge is positive means electric field everywhere is away from it. If the charge is negative, everywhere the electric field is towards. But always at every point electric field is perpendicular to the surface. That's why angle between electric field and area, that means area direction means normal to the area you have to consider. Electric field is perpendicular. Area direction means perpendicular. So both are in same direction. So angle is 0. That's why cos theta 1. So simply I have taken E integration ds. So E into integration ds means total surface area. What is the total area of a sphere? 4 pi r square equal to Q by epsilon naught. Then E will become Q by 4 pi epsilon naught r square, or else KQ by r square. This is the electric field at any point outside. Now the final one, case 3, that is if R equal to capital R. That means on the surface. On the surface. Now on the surface when you consider capital R equal to small r, Then E, this is like E at B. Now E at C will become KQ by capital R square. Small r will become now capital R. So this is the electric field due to a thin spherical shell. So that the final conclusion EA 0, EB KQ by R square. Sorry, this point is C. Outside point C and on the surface B. And outside point EC equal to KQ by R square. So this is what the electric field due to a thin spherical shell. Now the fifth question is, derive the expression for drift velocity. Derive the expression for conductivity of a material or sigma equal to Ne square tau by m, where symbols have usual meaning. Define the term mobility. So lot of things are there. See, previously many times they asked this question. Now the very first thing is derive the expression for drift velocity. First let's try to define drift velocity. See, what is drift velocity is when you consider the conducting wire, the electrons will move freely in random directions. But when you apply external electric field or external potential difference, then electrons try to move or align in the direction of, in the one particular direction with one average velocity. So the average velocity of electron between two successive collisions is defined as drift velocity. So now when you consider an electron, now it is moving randomly. At one point it take collision with one atom, then it traveled to some other distance and it came to collide with another one. So during this it traveled some distance. Now electron experiences an electric force in the presence of an external electric field, nothing but electric potential difference, whatever you will apply. So that what is that electrostatic force is Fe equal to Q into E. Here charge of electron is E into E. Just like when you take a conductor and you apply some potential difference, then there is some direction of electric field, then electron will experience force in the opposite direction of that of electric field because it is a negative charge. So that this is the electric force. So acceleration A will become force by mass, that is E by m. So this is the acceleration with which electron moves. So before applying application of external potential difference, electrons move randomly, freely in different directions. Now after application of external potential difference, they try to align in one particular direction. In that process, they take collision with the atoms, and between two successive collisions, so they travel some distance, and time taken between two successive collisions collisions is called, that is called relaxation time. And that relaxation time we represent with a symbol tau. So that now acceleration is constant. So acceleration is constant means we will take it as uniformly accelerated motion. So that v equal to u plus at. But after taking collision with one atom, it will come to rest. Then it will accelerate. That's why u equal to 0. So v equal to u plus at. That is E t is tau by m. This is the drift velocity. Now, this is the velocity. Now, this is the equation for drift velocity where the symbols have their usual meaning that E is external electric field, tau is relaxation time, m is mass of electron, E is charge of electron. That is what you need to first understand. Then, you have to derive the relation for conductivity. Now, conductivity relation they are telling that Ne square tau by m. So, the conductivity of a conductor sigma nothing but 1 by resistivity equal to Ne square tau by m. Now, to prove that, first consider a conducting wire and apply a potential difference V across its ends. Just like this is a conductor. Now we applied some potential difference V. Now the very first thing is according to Ohm's law. According to what? Ohm's law, V equal to IR. Now, where V is potential difference, I into R, and the length of the conductor you consider L, then the potential difference equal to E into L implies E into L equal to I into R. But resistance of a conductor equal to rho L by A, where rho is resistivity and A is area and L is length. Now if you substitute EL equal to I into R equal to rho L by A, now L cancel. So E equal to I into rho by A, and current in a conducting wire I equal to NEAVD. This is the equation of current in a conducting wire. So E will become, I means NEAVD into rho by A. Now AA get cancelled. Now NE rho into VD, where NE rho into VD is EE tau by M, just before we have derived. So EE get cancelled. Now bring M this side, divided by N into E, NE square tau equal to rho. Now we got the equation for resistivity, but we want conductivity. Now conductivity sigma equal to 1 by rho, that is nothing but reverse, it will become Ne square tau by what? M. So you have to use current equation current in a conducting wire equation. You have to use resistance of a conductor equation. You have to use Ohm's law. You have to use relation between electric field and potential. Then you can get the final result. So that this is what the final, where N is number of electrons per unit volume, nothing but electron density, and tau is relaxation time, m is mass, E is charge of electron. And final thing what they are asking is, in the same question, define the term mobility. So the mobility, the term mobility means, mobility, it is denoted by, it is denoted by mu, and it is defined as drift velocity per unit electric field. Drift velocity per unit electric field. That is what we call it as mobility. So mobility mu equal to drift velocity per unit electric field. So per unit electric field, how much drift velocity the electron will acquire, that we call it as mobility. It's just like a ability to move. So that is what all the things. So hope you understood everything and try to practice all the derivations, and we'll continue 5 more questions in part 2 and next 5 more questions in part 3. Total 15 important questions. And then after that, I will try to discuss the 3 mark questions, right? So thank you all of you. We'll continue in the coming class.